Just a quick safety check. We're using 0.1 molar and 2 molar acids. And because we're using such small volumes, it's probably a good idea just to get a paper towel to dry up the remaining liquid and put it all in the bin, including the leftover pieces. But we'll be using less than 30 mils or even 20 mils because you should be using less than 1 mil per group. And so these can all go down the sink and in the bin. Make sure you recover the copper, zinc, and the unreacted copper and the zinc and silver pieces, the ones that didn't react, and put them back into the vials. So to start with, we're just going to react the acid with the 4 metal pieces. And you can see the copper and the silver don't react. They're less than hydrogen on the reactivity series. And magnesium's reacting quite a lot. And so that pretty much solidifies magnesium as the most reactive. And you can see the equations there. And you can look at the zinc, you can see little tiny bubbles form, so it's slowly reacting there. And so for all these reactions that occur, I've written the full balanced reaction, then the ionic equations, and then I've separated the oxidation and reaction half reaction. So you can see the magnesium is oxidized, therefore it's the reducing agent and it's the most reactive. And the hydrogen for the first reaction is reduced in the oxidizing agent. And then I've repeated those reactions for zinc. Okay, so now we're moving on to single displacement reactions to look at the reactivity. So I'm adding copper nitrate to everything but the copper. And then I'm adding the silver nitrate to everything but silver, because those things are not going to react. You can see just a couple of drops. So that's just like 0.2 mils at most. And then adding the zinc nitrate to magnesium, silver and copper. Just a couple of drops each. And then finally magnesium nitrate to everything but except for magnesium. So just looking at the silver nitrate there, you can see that all three metals, have reacted. And so I've got the reactions there. You can see because they have reacted, that means the Ag plus has gone to solid. And so therefore it has been reduced in all cases. And so it is the least reactive. Now, this one's quite helpful. The copper is meant to react with the magnesium, but I can't see anything reacting here. It does react with the zinc as it's meant to, and it doesn't react with the silver, so that is the key one. It tells us that copper is more reactive than silver. And that's because the copper is not being reduced, and the silver is not being oxidized. If the silver was oxidized, it would be more reactive. If the copper was reduced, it would be less reactive. But the copper is more reactive and the silver is less reactive. And so that's the key, that we can finally put them all in the correct order. And this one here, not fantastic either. The zinc has reacted is meant to react with magnesium, but didn't. Maybe it has, but I can't see it because it's silvery, who knows. And the silver and the copper didn't react. Lastly, as expected, the magnesium doesn't react with any of them, neither the zinc, silver, or copper.